Right? Yes, perfect. Hi, my name's Adi Krishnan, and I'm the product manager on Amazon Kinesis. Thank you very much for joining us today, this afternoon. Gosh, it was a year ago right here that we launched Amazon Kinesis, fully managed service, streaming data ingestion that enables continuous processing, and it's amazing that we can still have all of you here with us looking to learn a bit more about the service. There's a lot of content here today for us to walk through, so I'll keep it snappy, keep it moving, and it's a full 45 minutes of content, and we'll spend time. Any questions, take it afterwards, or of course you can always reach out to any number of us on the team. But a quick show of hands, how many of you are current Kinesis users? Okay, I would say that's about 15–20%. How many of you are here sort of know something about Kinesis, but really would appreciate a little bit more of a 200 level? Okay, perfect. Okay. So this session is a deep dive. It is a 400 level session, which means that there is some amount of knowledge that we assume going in. But given where you guys are and given our kind of customer feedback driven nature, I might end up spending some more time on kind of the basics, but we'll definitely run through some of the more interesting concepts or things that you must know, or things that we wish we told you a year ago, right, when you start building the applications with Kinesis. So just a quick note first on actual scenarios that we've seen in the last year pop up. Now, streaming data is, all said and done, cool, sexy topic for us to talk about, but it's still in its infancy. Which means that what we notice is use cases going through this progression as users discover what streaming data can do for them. And indeed, the most prominent use case, which is kind of the scenario number one in there, is really just continuous ingestion of data to deposit it into some store like S3 or Redshift or some other database. So it's not fancy real-time analytics. It's really just movement of small, fast-moving data that's coming from your log servers, application servers, clickstream data coming from your sensors, your mobile apps, what have you, but just simply that kind of small, fast-moving data that's being produced and generated continuously, to capture that in a durable, reliable form, and then move that after some set of light transformations, light reshaping into some versatile store like S3, after which you can do something meaningful with it. So that's kind of use case number one. And regardless of what vertical you're in, there is some flavor of accelerated data ingestion that is happening. Now, as soon as we see customers do that, there is always this innate desire to say, well, what if I can now generate KPIs, metrics of that streaming data? I might want to display that on a dashboard, create some sort of a live site metric. A number of these other use cases normally related to visualization. I'm not necessarily talking about deep, rich visualization, but this is mostly time series data, windowed analytics, count, sums, averages, weighted averages, Bollinger Bands, stuff that is bread and butter, but has enormous applicability across different verticals and different use cases, because the math is the same, the output feels a little different. But that's where we find kind of the stage two. And where we're seeing now some customers move into is this notion of responsive data analytics, where this streaming fresh data is now part of some other richer feedback loop. So nearline recommendation systems. How do we optimize and enrich what we know about a given customer who's on the website right now, given their past visitor or buying history? It comes into play in auditing use cases. Well, what happened in the past when I saw similar data? So now that fresh stream data is looking into another data store. Stuff is getting enriched. So these are definitely more full-blown applications, and we see customers move into that kind of level. So it's easy to remember things in three. And as you think about your journey with streaming data, it's possibly going to be helpful to say, well, where am I? Where would I like to be as step one and step two? OK, so quick overview. For some of you, this is old hat. For the rest of you, probably the first little cartoon diagram about what Amazon Kinesis is. So managed service, streaming data ingestion, continuous processing. So 3 things that I'd like for you to remember. The actual data source can be any producer that can do an HTTP call, right? At the end of the day, you put data, log servers, application servers, mobile phone apps, as I mentioned earlier. You put data into Amazon Kinesis. AWS-style authentication authorization happens on the front ends, and this small, fast-moving data lands into a stream, the entity that you own and operate. All data gets 3-way replicated across availability zones. So this is durability that you just get with the service. No special knobs, no special levers, no config changes that you need to make. This is durable. This is a highly consistent way of storing data. And the reason that is important in the Kinesis world and the streaming data world is that as soon as the data hits the service, you want the ability to consume that data. And you want to consume that data in multiple concurrent forms. This is the second facet of stream processing, which is small, fast-moving data that you capture quickly. And then invariably, what you want to do is drive multiple different consumers that are independently but concurrently processing the same stream, but for different use cases. So in the little cartoons that you see on the right-hand side, you might have an application that is consuming that streaming data, applying some business-specific aggregate, and then emitting that data into S3. That's its job in life. You could have another application that's concurrently, perhaps trailing 15 minutes behind the first one, has its own independent cursor on the stream, and is reshaping the data and then emitting that into Redshift. So now you've got fresh data that you've captured via Kinesis, transformed, loaded up into your data warehouse in 15 minutes or less, for instance. It could be shorter, but let's just pick that number because it's way better than end of day. It is way better than hourly. And it's really powerful because now all of your data sits in a place like Redshift. It could be another data warehouse. But now the rest of your organization has access to that freshest data. You could have another application that's generating real-time KPIs and dashboards. And all of these applications are concurrently consuming from the same data. And this is, at the end of the day, the power of streaming data, that you can collect all of your data, collect it continuously, and expose that data to multiple different stakeholders by way of those specific applications. Let's get a little bit more concrete. In Kinesis, you're looking at two components, if you will. The first component is managed real-time data ingestion, so capture and storage of data at scale. And when you're building such a system, you need to have certain properties. We care a lot about scale. You might be at a few megabytes per hour today, but your infrastructure you might end up sending a few gigabytes, a few terabytes, and we're seeing that growth happen. So one thing is to not necessarily get turned off by the notion of, oh, this is really about scale. It is, but it's really about capturing your data as quickly as it's generated so that you can do something meaningful with it. It has to be durable, because this is your data that's being captured, your customers' interactions, your billing data, your metered data. And you don't want to lose it, because in many cases we've seen losing data literally is losing money, because the bill that you'd have computed from that data is now cannot be done so. It has to be elastic. There's a hit application that you create and suddenly you drive 5 million new users. You want your data ingestion engine to be able to scale elastically to consume that data. And last but not the least, something that's unique to streaming data system is that you want to have this notion of a replayable read, right? Because you have multiple applications, each of which can be at different points in the stream. One is right now, right here. One is 15 minutes behind. And maybe you have a slow coach application that is coming along 2 hours behind wall clock time. One of these applications, any of these applications, all of these applications might fail. When these applications come back up, they want to resume processing from the pointer where they left off at. So that's the notion of a replayable data. So that's kind of the core real-time ingestion component. Then there is the notion of continuous real-time processing. Okay, the data is stored and captured. It exists as an ordered event stream that you can now consume it from. But how does one go about authoring a stream processing application? And that sort of an application, too, has certain characteristics. It's elastic. You can go from 10 megs per second to 100 megs per second. And how does your application react to that new incoming data? The application needs to have the ability to load balance the incoming data across all the available instances on which it's running. You do care about fault tolerance. You want the ability to easily checkpoint the data, to replay the data in accord with the ingestion pipeline. And last but not the least, as I mentioned earlier, you want to have multiple numbers of these applications, because once you start streaming data, there's always this desire to plug in that next application to see what else you can do in the business. And you want to do all of this in as managed a form as possible so that you can get on with business. The end-to-end latency has to be as low as possible, because remember, we're looking at a transition from a batch-oriented view where you used to collect all the data in your ingester tier, spool it to disk, after a few hours, maybe end of day, snapshot that data into something like S3, run a massive Hadoop job that ETLs the data out and then loads it into some processing engine. We've all done it. We still do it. In fact, I would be interested in a show of hands of how many of you have this batch-oriented way of collecting your own data and then ultimately getting into some persistent store. That's great. The rest of you are lying. And then last but not the least, one of our goals was not to create yet another trap or silo for data, right? You want to be able to move the data into multiple different processing engines, data stores, many of which a lot of options exist, including options we announced today. And we want to be able to move the data into all those different stores so that you can apply the right tool set for the right job. Okay, so some more concepts. A stream is a managed entity that you create. It takes 3 clicks on the console to create a stream. As part of the stream creation process, you say how many shards you'd like. A shard is a unit of scale and a unit of parallelism. Each shard can do a megabyte per second in, 2 megs per second out, which means, let's say you're generating 100 megabytes per second across your infrastructure logging tier. You'd say, Kinesis, give me a stream with 100 shards. And in 10 or 12 seconds, you get a fully managed capability to durably capture, reliably store, elastically scale all of this 100 megabytes per second of data as quickly as you can throw it inside of Kinesis. Kinesis is a moving time-windowed buffer on that data. All data by default is retained for a period of 24 hours, and the oldest data is expired out of the system. So good news, bad news. Good news is all data is stored for 24 hours, which means that your consumers have at least that much time to pull the data off the stream and do something meaningful with it. On the downside, you have 24 hours. So you would want to read that data as quickly as possible in your use cases. You're not locked into the capacity that you set at time of creation. At any point during operation, you can say split that shard, which means there will be 2 where there was 1, which means you effectively double the capacity of that shard. At any point during operation, you can say merge the shards. You can take 2 adjacent shards of capacity and fuse them into 1. So these are all online operations, i.e., you can put data, consume data, but the stream still remains in operation while it's being scaled up or scaled down. These are operations that you explicitly invoke, and we'll talk a little bit about practices around that. So how do you put data into Kinesis? You put data into Kinesis using the put record API, which has your stream name that you've created, the actual data blob, the log line, the sensor data, the clickstream data, as the case might be, and this thing called a partition key. You own your partition key strategy. It is a way to distribute the data across all the shards in your stream. When you put data with a given partition key, we generate an MD5 hash of that partition key, which falls on a certain hash key value, which will always be inside of a hash key range of any given shard. This is interesting because every time you put data in that stream with that partition key, it always gets routed into that specific shard. And as we'll discuss later, there are a couple of mindsets around this. You can think about Kinesis as just a way to capture all of your data, right? So just buffer my data across all the shards in my stream. It doesn't matter where they exactly land, because you just want to capture your data. The other mental model is to say, wait a minute, I have a streaming map reduce capability, because each time I put data on a partition key, it always lands on a given shard, which means on the other end, when the consumer is picking data from the stream and from that shard, it will always see all the data that landed on that shard. So that's the streaming mapper concept. And in our experience and best practices, customers see it, they fall in one of these two camps. Mostly, customers fall in the camp of, I just want to get all my data in. I'll generate random partition keys and let them land wherever they land, but I just want it all captured as quickly as possible. Every successful put is acknowledged with a monotonically increasing sequence number per record that's put in the stream. So, as we were discussing, determine your partition key strategy, right? You decide whether you're managed buffer or you're streaming MapReduce. If you're going to go down the route of a managed buffer, choose a high cardinality of partition keys with respect to number of shards. You want to do that because you don't want to get into a hot shard or a hot partition key problem. What will happen then is you will get a provision throughput exceeded error from Kinesis, documented API, response syntax, and what you're going to face potentially is, oh, can I not get any more data in? And while the rest of your shards might be running cold, might be running mostly empty. And you might want to make sure that you generate enough partition keys such that the data is uniformly distributed across most of the shards in your system. The second one, as we discussed, was the streaming mapper concept. This is useful. We do some of this internally ourselves. We think about using partition keys on device types. We think about using partition keys as a certain application version. And so all data related to that application version lands on this family or this set of partition keys. That's useful, because then our application that's consuming that data can do something meaningful with it. Provision adequate shards. Now, this is kind of a no-brainer, but it is a provision model at the end of the day, which means that there is this implicit contract between the Kinesis service and you as a user to say, you will tell us beforehand how many shards you want in your capacity. You want to provision adequate shards, obviously, for your ingress. If you're sending 10 megs per second, you want to have at least 10 shards in your stream. But you want to do a little bit more. You always want to have some headroom. And we've seen customers have up to 20, 30, 40% headroom for the event of spiky, in the case of spiky events. Mostly it's okay because Kinesis shards happen to be remarkably cost effective. But you also need to provision adequate shards for your egress needs. Remember, you might have multiple applications consuming from the same shard. And a shard can do 2 megs per second egress, right? So what if now you have 3 shards? What if you have 3 applications or 4? Now you're running into a world where what dominates your sizing and your capacity is the number of hungry applications you want to feed, more so than even the data you're going to put in. So you should bear that in mind. Also include some headroom for the catch-up scenario. An application might fail. It might fail for 4 hours. It comes back up, it's going to request all the data, it's going to be super hungry, you got to feed that guy, which means that it might end up consuming all of your shard egress bandwidth. So for those catch-up style scenarios, you might want to think a little bit more about, depending on the application, the criticality of the application, if you should have certain more shard capacity allocated into your stream. So provision adequate shards. Next best practice for putting data. Sometimes it's not a terrible idea to do kind of a micro batch before you do a put. In many use cases, we've seen that the individual data record is a few hundred bytes. That's it. A single Kinesis payload can be as big as 50 kilobytes. So there is some wisdom in saying, I'm going to help aggregate 50 or 100 of these individual few hundred byte records and then execute a put record call. HTTPS put record calls, put calls, cost some efficiency, they cost some CPU cycles. You might want to make sure that you optimize for those kinds of put record calls. And to enable you to do that, there are options. you could use some of the great open source collectors and agents like FluentD or Flume. In fact, if you use FluentD, it'll generate as a collector that's, say, running on your log server. It can generate random partition keys. You can set a certain number of threads so it can buffer data locally on your producer in case there's a network issue or it's unable to reach the service, and then it can retry on your behalf. So this is stuff that you can just leverage using something like FluentD or Flume. The GitHub where it's available is right there on the slide itself. You may not want to do that, however. You might say, no, I'm going to just use the AWS SDK, in which case what we've noticed is that using the async producer, which surprisingly lots of people discover for the first time when we talk through high throughput data ingestion, is a good idea. Now, there's a default thread pool executor within the AWS SDK in all the languages available that can buffer that can run up to 50 threads in tandem, so you can get to a reasonable throughput efficiency. Because if your server, your log server, for instance, is producing 1,000 records per second, you might have to do something special in there to get the data onto Kinesis. So using something like the async producer is a good idea. You might also face a choice about, well, what if I run out of 50 threads, right? You might have to now think about some local queuing strategy. So using some of these options like either a synchronous queue or an array blocking queue available as part of the async producer are good options to work through in your specific use cases. Because the goal here is to do some pre-batching to get to a higher efficiency throughput inside of your Kinesis stream. You can do other things. You could use something like Log4j. Obviously, it's not a traditional collector or agent in the traditional sense of the word, but as part of your application, you can use Log4j, also available for putting data into Kinesis. You can do a number of different things. You can set max retries. You can set the buffer size. You can set thread count, so on and so forth. But this is, again, just available for you to pick up so that you can get to putting data most effectively. So it is a provision model, however. And what happens when you start getting provision throughput exceeded errors? Now, you will get a provision throughput exceeded exception when either you're sending in more data that you've provisioned for, and this can happen either by exceeding the megabytes per second on any given shard, or by exceeding the TPS rate on any given shard. So let's say that one shard can do a megabyte per second, and you try and send 1.1 megabyte per second, you'll get a throughput exceeded error. It happens. So what do we do in those circumstances? It's normally good to go in with that knowledge. For the first set is, well, you got to retry. It's always a good idea, and you'll probably do that retry logic even if you use the core AWS SDK. The next action will be to say, okay, I'm going to reshard, right? So looks like I don't have enough shards, or I've come across this hot shard that is giving me this provision throughput exceeded error, and what I need to do is split that shard to get into more shards. So the way you would want to do that is, first and foremost, track the core metrics like put record bytes, put record latency, and the success count that are all emitted on a per stream basis. One of the important parts about making something like Kinesis a backbone for your logging data is to make sure that you're paying attention to these metrics. For instance, you provisioned 100 shards in your stream. You know it because you provisioned it, which means that you cannot, in theory, get greater than 100 megs per second. If your put record request bytes crosses that threshold, or if you're wiser, you would probably say a 70% or 60% of provision threshold, it's normally a good indicator back to you to say, okay, I think something is up. I must initiate a split shard API command. Now, I realize that I haven't talked through the split shard API, on account of the deep dive nature of the session. It was an assumption, probably an incorrect one. The split shard API is documented in our API reference guide. So for those of you who are online, you should probably check it out. It has its own kind of the sister version, which is the merge shard, which will take two shards and combine them into one. Documented APIs, please have a look at split shard and merge shard. So, but sometimes that stuff is not enough, right? You might say, I actually want on a per shard level understanding of how's my data doing, not at a stream-wide level. So to do that, you have a couple of options. The partition key that you use, as you know, is put ND5 hashed, a hash key is generated. So the first thing would be to keep track of the hash key values of the records that you're putting in. You can do that because the partition key that you send, you can derive an MD5 hash from that. The second one is to keep track of the shard IDs themselves. The shard IDs are returned, there's a method called getShardID as part of the putRecordResult object that you can invoke to get back to an idea of which shard did the data land into. And you can maintain on the side for a per shard ID basis how many times have the hash key values hit, i.e., how full is my shard? And that information can normally be used as a best practice to say, I think shard ID 00003 is the one that's going to get filled or is likely going to be a hot shard. That shard ID then can be passed as a split shard API command reference, and you can just say split down this hash key, and you'll get 2 shards, where instead there was just one, and this is again an online operation. So this is normally a good best practice when you're sending in a fair bit of data. I'll have to say this though, for a lot of customers, because of Kinesis' cost effectiveness, you just run with more shards. And you can forget about everything I just told you. You're provisioned enough, and life is good. Yeah, well, there's that. But we can do something better. So how do we get to this scaling of Kinesis shards thing? Now, the good news is that there is another utility that one of our fantastic solution architects wrote, and this is kind of the shard scaling utility. And that's what it looks like. It takes your stream name and obviously the region in which you run the stream itself. You say if you want it to scale up or scale down. You can either give it a count, i.e., I want to scale up by 10 more shards, or you can give it a percent, scale up by 10% more. So which is normally maybe a little better strategy than saying, when I start getting a provision throughput exceeded error, I'll just double the number of shards, which I've seen many people do. It is a peace of mind, simpler approach, but perhaps if you're looking for the next level of optimization, then you might want to do something like this. Of course, you can use your own, as complex as you want it to be, shard scaling strategy as well. But this is a neat way to just get started and not end up highly over-provisioned, but be somewhat rightly over-provisioned. Okay, so this is a good place to checkpoint real quick, because we're talking about sending data into Kinesis, variety of different ways. AWS SDK, also available in the mobile SDK. There's this thing called Kinesis Recorder inside of it, so in case that's part of your mobile apps, you can put data in Kinesis if you have the mobile SDK compiled in. We talked about Log4j, Flume, and Fluentd. Let's pivot. Let's pivot into consuming data. So this was part one, right? So we have ingested data, done so hopefully with a few best practices, partition keying, provisioning adequate shards for ingress and egress, as well as thinking through scaling and what the right model could be. This is part B. How do you build applications? So let's talk through some more theory about the Kinesis client library. This is an open source library available in Java and also in Python for all developers. The source is available on GitHub. And it is one way to start building stream processing applications using Amazon Kinesis. The application you build is deployed onto your set of EC2 instances. So remember, assembly is required. This is a developer-oriented offering. The application itself could be as simple as aggregate move data to S3, or it could be the most wonderful online machine learning algorithm that you're writing. It is an application that has to be written. The application is written using the client library. You can deploy it onto your set of EC2 instances. And here are a few components that you'll become quickly aware of, if not already. There is the notion of a worker. That is something that the Kinesis client library that I've abbreviated as KCL will manage on a per EC2 instance basis for your application. There is a record processor factory that will create your piece of business logic that you've already authored into it, and spin it up as a process. The record processor becomes then that processing unit that consumes data from a shard and actually does your processing. That's the iRecord processor. The Kinesis client library uses the iRecord processor interface to communicate with your application. So let's say your application is, I read the data that's being popped into me. All I do is that I wait for 1,000 records, I run a gzip, and then I flush it to S3. Let's say that's the reason of existence for your application. That logic would be implemented as part of the iRecord processor. That's where your logic will live. There's a whole bunch of housekeeping stuff, startup shutdown stuff that the KCL takes care of you, but really where you focus is in that iRecord processor interface. So what the KCL is going to do then for you is that it's going to spin up a record processor per shard. So if you have a 2-shard stream, KCL on your application's behalf is going to spin up 2 record processors. As an application developer, you don't worry about how many shards are there in a stream at any point in time, because that is something that will change, something that you will change, in fact. And what you want to be focused on is in the core application logic. And what the KCL is going to do is that it's going to first spin up a worker per EC2 instance, because you could have many instances in your application. It's then going to spin up a record processor per shard. It's going to create a shard management table on your application's behalf. Inside of it, it's going to write down how many shards there are in the stream, the ID of that shard, the beginning ending hash key of that shard. It's going to allocate a record processor per shard, and it's going to enable you to drive checkpoints. So you can say checkpoint after each record processor sees 100 records, so on and so forth. It will balance the shards and the record processors as your EC2 instances grow or shrink. It will balance shards and workers as your shards merge and split. So again, as an application developer, all of your focus is in the iRecord processor logic. And the Kinesis client library manages all of that state. For those of you who've wrestled Zookeeper to the ground, know how that can be a challenging, time-consuming task. And think of this as kind of a lightweight distributed coordination capability for your streaming application, something that you would have had to otherwise manage by yourself or through some other rich but complex framework. That was core KCL. Let's talk about this companion library that not many people know of again, that customers over time have picked up and has come up as a best practice, which is that one of the biggest use cases, as I said earlier, is moving that data into S3 Redshift. The Kinesis connector library is built on the Kinesis client library. As the name suggests, it's a library again. It's also open source and available for all developers. And it defines this pipeline inside of it. The pipeline itself has a transform, filter, buffer, emit set of interfaces that you can then override. And we'll go into these in successive levels of detail. But the key thing here is there's a client library that helps you get up and running, and a connector library that allows you to then cobble together your streaming data with these destinations like S3, Redshift, Dynamo. We also have this for Elasticsearch. So if you want to pump all the streaming data into your Elasticsearch cluster, that too is possible, because the connector library has been extended to support Elasticsearch as well. So in the guts, the record processor, the Kinesis connector record processor is the base class. It implements the record processor interface of the Kinesis client library that we saw earlier. And it contains a few key classes, the transformer, filter, buffer, and emitter, as we mentioned earlier. And let's dig into these in subsequent levels of detail. So the first one is the transformer class. You want that because your data might be coming through in any format that you've put in, and you might want to transform it per some business-specific use case. So for instance, you have your raw JSON-style data, and you want to convert that into some CSV-style data for that is time-stamped and by event type, a billable event, a new customer install event, as the case might be. So transforming is the most foundational step, typically, as you consume the Kinesis record from the stream, and then use the transform library here to define this custom serializer, deserializer. There are a couple of, and need to send this, because it's a pipeline, the transformed, the output of the transform stage should be in a form that the emitter class in the next stage would be willing to accept. You have a string-to-string transformer, you have a basic JSON transformer that's available right now within the library. The filter method. Very frequently, even though you capture all your data, you want to reshape and rescope a lot of it out. And that's kind of the iFilter method. Really, there is a keep record and an all pass. You want to keep all your data, or you want to filter a bunch of it out. Quite simple, but in many times, customers have not discovered this. So it's a useful method to undergo in your applications. Then you have the buffer. The iBuffer defines a system for batching all the data, portions of the data that you've received via the Kinesis stream before you send it along its way. Normally a good idea to do some level of buffering or micro-batching, as some people might call it, before you send the data along its way. For instance, if you're putting data into S3, normally a good idea to buffer it up to a few megabytes in size to make that an efficient write. If you're going to send that data along to Redshift, also a good idea to do some buffering. If you're going to send that data into DynamoDB, maybe you do want to do batch puts. But always good to have that option as you're thinking about how do you buffer the data before you send it on to the next stage. So the connectors then that you need to be aware of, the S3 connector for batch writing files for ultimately storage in S3. And it'll use, by default, a sequence-based file naming scheme. Your mileage may vary. You might want to affix certain date, time, event type, and so on and so forth to prefix those files before they land into S3. But that is also possible in as much as it's available as source. The Redshift connector, which we'll talk about in some more detail, is more interesting because it actually leverages the S3 connector. There isn't yet a magical way to get the data into Redshift. S3 continues to be a great way to load data into Redshift. But the interesting thing is that it provides manifest support. So you can put the data into S3, create a manifest stream, and it'll execute the Redshift load from within S3 on your behalf. So let's look at some best practices as it pertains to processing data from Kinesis. The first one is don't run an application on a single EC2 instance standalone. Put it in an auto-scaling group. Even if you're not looking at scale, putting it in an auto-scaling group just for the notion of high availability, such that at least one instance is always up consuming the data, is a good idea. So basically a scaling group of one. But in general, it's a good idea because your incoming data might be spiky, right? There might be legitimate cases where you're sending a lot more data and you want to make sure that this consuming application, as simple or as complex as it might be, running on EC2 instances, has the ability to respond. And the KCL interoperates with the auto-scaling group. So all the shards, the workers, the record processors that we spoke about automatically get load balanced in response to these incoming, with response to this increased load on the system. You can use any set of scaling metrics. You can use the metrics you know and love that are instance-based, CPU-based, so on and so forth. You can also use Kinesis metrics. So scale, kick off, or trigger the auto-scaling group when the incoming data hits greater than n megabytes per second as captured by put record bytes metric. So as you're writing this application, you'll sometimes run into this issue of saying, why is my consumer slow? i.e., I know I put this data, but is my consumer falling behind? How do I get to know that it's going to catch up? Metrics, again, are normally a good idea to, as a first instance, detect why is my consumer slow. And in that journey of figuring out why is your consumer slow, why is your stream processing application not running with the freshest data that's into it, your best friends are get records iterator age and get records latency. Specifically, get records iterator age. Now, the iterator is that cursor that any application grabs onto the stream itself. So if that iterator age is old, what that means is that your consumer is seeing older and older data. In the streaming world, older data means it was put a longer time ago than data that is quote unquote now. So you might want to watch out for get records or iterator age to say, and maybe even set an alert against it to say, well, I was really expecting my record processor and my consumer to be running under this millisecond threshold. Remember, it's in milliseconds, not seconds, minutes, or hours. So there'll be many, many zeros, and make sure you divide by 100 as appropriate. And it's normally a good idea to pay attention then to the get records iterator metric. There are a bunch of other metrics that are also useful to get a sense for how is my processing application doing, but that's your best friend. It's a little unusual to call this a best practice because in many cases, that is the scenario. But build a put to S3, an archive to S3, or a flush to S3 consumer application. Always a good idea to capture all of your data and keep it in S3 because not only might you legitimately need it to extract out via EMR or run whatever other process on it, including move it to Redshift, but also in the case something happens, your application is down, your downstream application is down, you have a source of truth where all of your data has been captured. As we talked about in the iBuffer case, you can trigger the buffer flush based on number of counts, amount of data, and time since last flush. Your mileage may vary depending on how you want to invoke the flush of data into S3, but these are your three big options for you to kind of work through when it comes to I have gathered my data, I've transformed it, potentially filtered it, and now is when I'm going to actually flush it after buffering. So normally a good idea to keep that in mind. One thing that will come up time and time again in several use cases is, okay, we're talking about a stream processing system with varying amounts of load in it, and there is the notion of duplicates, right? There is the notion of my application failed, it came back up, it used the checkpoints, that was great, but it ended up reprocessing data. So idempotent processing, or at least more generally speaking, getting to this, it says at least once here, it really should read exactly once, is a much, much higher bar. And that typically takes a lot more work from a developer and architect's perspective to put together. Now, there are a few general purpose techniques that we've over time discovered as being things that give you maximum ROI, right, for the effort that you put in. The first one is any checkpointing that you write using the KCL that you can configure, do so after you've persisted the data. So in the S3 case, as we saw earlier, flush to S3, then do the checkpoint. That's normally a good idea. The second is the notion of duplicate processing. Duplicates can be introduced anywhere in the process. The core Kinesis service won't introduce one, but it can happen, for instance, your producer is putting data in, and it gets the ACK, except the ACK doesn't reach it, and it ends up retrying. So now the producer has put data twice, and the same data has landed on your stream twice. There is no inbuilt dedupe method inside of core Kinesis, and that will be a problem that will have to be tackled at the consuming application layer. And it normally helps to have the authoritative data repository. Could be DynamoDB, could be some other key value store, could be Redis, could be S3. But you want to make sure that that place is where you deal with duplicates. Moving data into Redshift can also be accomplished using the Kinesis connector library. So as we talked through earlier, transform, filter, buffer, emit. And as we said, it uses the S3 underneath to move the data into Redshift. There isn't a direct mechanism yet. A good way to do it is to use the Redshift manifest emitter. So how it's going to work is you have the incoming Kinesis stream. You define your S3 manifest pipeline using the connector. You write the data with the connector into your S3 files. You use the Redshift manifest emitter to create a new one-shot stream. The data in that one-shot stream is simply going to be the names of the S3 files. So that's your manifest. What the application can do for you then is invoke a Redshift manifest copy command on your behalf using the manifest stream that was generated and the file names within it. So this way you'll get to a little bit more of a reliable way to load data into Redshift via Kinesis and run the risk of faulty loads less or so. Of course, as part of this journey, you want to fine-tune your application a little bit. You should think about what your checkpoint frequency should be, how big you want the connector buffer should be, whether you should be using an all-pass filter, or do you want to remove a bunch of data that's already been consumed in the stream itself. But by using the manifest connector, you'll get into this better data load into Redshift. And customers who have done this have gotten to a much more reliable 10 to 15-minute load of data into Redshift, which is, as I mentioned earlier, a big win from getting to a daily or 8-hourly or even an hourly data load into something like Redshift. It doesn't have to be Redshift. It could be other things. So I'll just leave you with a few things. Customers are using Amazon Kinesis, using some of these best practices to first get to a cost-effective, reliable, scalable way to collect all data of interest. The multiple consumer model means that you can decide at any point in time to introduce new or different applications that are also processing data from the same Kinesis stream without disrupting the other application. It's a fully managed service. Getting to a managed stream takes 3 clicks. And yes, you do invest some energy in building out an application, but ultimately, using things like the client library and the connector library, you get a little bit more productivity out of getting that code up and running quickly, especially if you're Java and Python programmers. And last but not the least, moving data into all of these multiple different data stores, the same fresh data that is transformed or morphed in aggregated in specific ways into these data stores means that it's not just for developers, it's not just for DevOps. Now, marketing folks can get data into Redshift. Your sales folks can get data. Other portions of your organization can all get access to that same data. And that, at the end of the day, is the most powerful fundamental shift that the streaming data model introduces. I know this was rushed, but you guys have been great. I'm around for more questions if you'd like to chat with me. But hopefully, you got through a quick flavor of Amazon Kinesis and what we've learned in terms of best practices on putting data and processing data with the Kinesis client library and connector library. Thank you very much.